Assalamualaikum warahmatullahi wabarakatuh. I am Al-wafiy, final year student from Faculty of Applied Sciences, major in physics in UiTM Aeropolis. I will present to you my final year project entitled Physical Properties of MG30 Based Solid Polymer Electrolyte, supervised by Dr. Kuzaim Al-Azim. This presentation will be divided into 5 parts. We have part 1, which is introduction, part 2, literature review, part 3, methodology, part 4, result and discussion, and for the last one is conclusion and recommendation for part 5. Firstly, the introduction. Okay, what is polymer electrolytes? Polymer electrolytes are plastics with an ion transport characteristic that enable ionic migration. Good polymer hosts for polymer electrolytes include highly amorphous, low activation energy for conduction, and have strong polar group. Next, carbonyl group from MMA group in MG30 act as coordination site for ionic conduction. MG30 exhibit low blast, flexible, and excellent electrolyte-electrode contact temperature at room temperature. Modified natural rubber has good solubility for many salts. So, for this experiment, the focus of this research is on the electrical and physical properties of new polymer electrolyte based on MG30 with ammonium nitrate. Okay, now we move to problem statement. In this research, we have 2 problem statements. For the first one is liquid electrolytes are suffered from leakage and tend to explode. And the next one, solid polymer electrolyte based on the polymer host have a low ionic conductivity and are suitable for application in energy devices. Let's see the objective of study in this research. We have 3 objectives in this research, which is the first objective is to identify the ionic conductivity of MG30 with addition of ammonium nitrate salt. Next, the second one is to study the physical properties of solid polymer electrolytes based on MG30 plus ammonium nitrate. And for the third objective of the research is to increase the electrolyte of mechanical stability and give good electrolyte contact. Significance of study. This study has been limited to MG30 based solid polymer electrolytes. Next, study the effect of anions and cation of ammonium nitrate salts on the property of MG30 based solid polymer electrolytes. The third one, preparation of solid polymer electrolyte using MG30 as polymer host. And the last one, characterize the polymer electrolytes that we get by using FTIR and EIS. Okay, now we move to chapter 2, literature review. The first one is polymer electrolytes. We have 3 types of polymer electrolytes. The first one is SPE, and the next one is GPE, and the third one is CPE. For SPE, solid polymer electrolytes, we have polymer host plus salt. Okay, for GPE, which is gel polymer electrolyte, it is created from polymer host plus salt plus plasticizer. For CPE, which is composite polymer electrolytes, we have polymer host plus salt plus plasticizer and plus filler. Doping salt. According to the research by Knight et al. In 2016, polymer electrolytes with doping salt can be more electrically stable and conductive in diverse solvents. In various solvents, doping salt in polymer electrolytes can improve electrical stability and conductivity as stated by Sukri et al. In 2017. So, according to the reports, ammonium salts are effective proton donor for the polymer matrix. Ammonium salt is commonly utilized in the manufacture of proton conducting polymer electrolytes. Proton donors to the polymer matrix have been found to be ammonium salts, as stated in the figures below. Okay, now for the methodology, which is in chapter 3. We have 3 main materials in this research, we use MG30 as a polymer host, ammonium nitrate as the doping salt, and we have THF, tetrahydrofuran, as the solvent. So we follow for the experimental procedures, we follow the solution casting technique. Okay, now I will explain about the preparation of this experiment. So the first one, we have 1 gram of MG30 dissolved in 40 milliliter of THF, and then we stir until it homogeneous, and we add ammonium nitrate salt in range of 0 to 40% weight percentage. Next, we stir again until it homogeneous, and we have the solid polymer electrolyte solution, and then we cast on glass petri dish and dry in the fume hood to form a film. So for the from the film, we characterize it using FTIR FTIR and EIS. We look into chapter 4, which is results and discussion for this research. As we can see, this slide is for FTIR analysis, and we have 3 figures. Let's look closely to the figure 1, which is pure MG30. So from this peak, we can indicate that the C double bond O bonding. Next, from this both peak, it is attributed to the strong C or C stretching bond, and this peak of C double bond C functional group can be seen clearly in this both peaks, which is with strong absorption band. Okay, now we move to figure 2, which is from this figure is show the 30% weight percentage ammonium nitrate is added into the pure MG30. So when ammonium nitrate was added into MG30, the C double bond O stretching band broadened and shifted to lower wave number. The C double bond O stretching mode of MG30 we can see at 1728.97 cm power of -1. Okay, this one indicates that there is an interaction between the oxygen atoms of the C double bond O groups of MG30 and ammonium ions via coordinate bond. The asymmetric stretching of NH4 plus ion is found in the region 1000 to 1400 cm power of -1, which is shifted to higher wave number where 30% weight percentage salt was added. Now let's see to the third figure, which is the figure shows the FTIR characterization of 9 samples of salted MG30 film with different weight percentage of ammonium nitrate. So we have sample A1 to sample A9. The figure illustrates that the pure MG30 and salted MG30 films by ammonium nitrate has identical functional group structures. The changes in peak intensity observed from the FTIR spectrum proves that the interaction between the polymer host, which is MG30, and stopping salt, which is ammonium nitrate. So from this graph, we can see that sample A7 have the most optimum conductivity. Now we look into EIS analysis. So we see in this slide we have two figures, which is the first figure we can see the conductivity versus weight percentage of ammonium nitrate at room temperature, and the next one we can see the VTF plot graph, which is for MG30 and weight percentage of ammonium nitrate in different temperature. Okay, now we look for the first figure. From this figure, the conductivity can be seen to increase when salt in concentration up to 30 weight percentage. The conductivity decreases when the salt content rises over this point. The increase in the charge carrier causes the conductivity to increase as the amount of the salt supplied increase. Ammonium nitrate dissociation rises together with an increase in salt concentration. And for the next picture, a temperature-dependent conductivity example that fits the VTF equation well over the temperature range of 303 Kelvin to 373 Kelvin. The coefficient, which is R power of 2, are close to unity at 0.29495. Right. Now, for the last chapter, which is chapter 5, conclusion and recommendation. The conclusion that we can get from this research is ammonium nitrate has an optimum electrical conductivity of about 6.3641 times 10 power of -6 S per centimeter. Next, when MG30 is salted, the conductivity value is higher than pure MG30. The next one, the electrical conductivity was improved by the salt addition, which is ammonium nitrate. And the conductivity of the MG30 and salt system is temperature dependent and follows the thermally assisted VTF behavior. We have reached the end of my presentation. So the last part is recommendation. The first one is to increase the electrical conductivity of solid polymer electrolyte. Additional study on the growth of the polymer electrolyte should be carried out by continuing the process of making composite polymer electrolyte. So the next one is utilizing the polymer host copolymer can avoid the need to remove the plasticizer afterwards. And the last one is, when adding inorganic fillers to polymer subsystem can improve transport qualities, resistance to crystallization, and the stability of the electrolyte interface. I sincerely appreciate your attention for today, and that brings us to the end. Thank you so much for your interest and attention.